Okay, video solutions for slope and similar triangles. So it says find the slope of the hypotenuse from the triangle with the following points. Okay, when we find the slope of the hypotenuse, we don't use the Pythagorean theorem because we're not finding distance. So the first thing from class is we decided this didn't work. So when they made this up, they made a mistake. So we changed it to 7, 4. So let's plot the points. I have 1 at the origin. Then I go over 7 and up 4. And then over 7 up 0. Okay, let's go ahead and connect those. And you can see that we make a right triangle. Now, when we find slope on a graph, we know that we use the slope triangle. Well, in this particular setup, we actually are finding the slope triangle with the legs. Here's 4, and here's 7. So it's as simple as slope is rise over run. So we know the rise is 4, and the run is 7. So the slope of that hypotenuse, we'll call it C, is 4 over 7. Remember that it looks like a fraction, so we have to simplify if needed. Okay, next one, same type of problem, so let's plot the points over 1 and up 3, over 1 and up 7, and then over -4 and up 3. Okay, let's go ahead and make our right triangle. And we're trying to find the slope of the hypotenuse, which is opposite the right angle. We know it's also the longest side. So just like the previous problem, we know that the slope triangle will be the leg. So this leg right here is 4, and this leg here is 1, 2, 3, 4, 5. So slope is rise over run. So we know it was up 4 and over 5. And we know that the slope is up and to the right, so it's positive. So we don't have to simplify, so there's our answer. Number 75. So let's plot our points again. -3, 2. -3, 3. And -5, 3. So this is just a tiny little triangle. Go ahead and connect them to make our right triangle. We know that the slope of the hypotenuse will simply be the leg, so that's 1, and that's 2. So we know slope is rise over run. So it went up 1 and over 2, but you can see that this line right here is up and to the left, so it has to be negative. Okay, 76. Let's go ahead and plot our points. Over 1 and up 1. Over 1 and up 5, and over 2 up 5. It's like a little thin one. Let's connect them. And we're trying to find the slope of the hypotenuse, which is right there. So we know one leg is 1. This leg right here is 4. So we know slope is up 4 and over 1. And our line goes up and to the right, so it's positive. So the slope is 4 over 1 or just 4. Okay, 77. Find 3 points that form a triangle that lies on a line with a slope of 3 over 5. Well, so we already know our slope. So if you think of what we just did, using the legs of the right triangle where the rise is going up and down and the run is going left to right, all we need to do is find 2 lines that make our 3 over 5 with that distance, or those distances, and then connect that third hypotenuse. So let's just start right here. It doesn't really matter where. Okay, so I know I have to go over 5 because that's the run. Okay, so that would be 5. And then I know I have to go up 3. And since it's positive, we can't go over here, because if I do that, then my slope is right there, and that's up and to the left. That would be negative. So I have to go up here 3. And it won't matter where you do it on the graph as long as one leg is 3 and one leg is 5 according to the rise and run. So now if we connect these, let's double check our work. So we know the rise is 3. We know the run is 5. So that means our hypotenuse is 3 over 5. It is positive, so that works. So anywhere on your graph, you could take this triangle and you could put it anywhere you wanted to. Wouldn't matter because they're not talking about any individual points. Okay, it says state whether triangle A and B are congruent, similar, or neither. We know congruent means exactly the same, and similar means the same shape but different size. Neither means that it's neither congruent or similar. It's a completely different triangle. Let's go and plot our points. Up over 1 and up 5, over 1 and up 9, over 3 and up 9. Okay, let's go ahead and connect them. Okay, so first of all, that's not even a right triangle. Okay, let's go ahead and do the next one. We'll do that in a different color. Let's do that in black. So over -3, up 0. Over -3, up 3. And over -1, up 3. Okay, if we connect those, we can see that this is a right triangle, so no way are they congruent or similar because they don't have the same shape. So the answer to this question would be no, or neither, I guess, is the answer from the directions. Okay, next one. Okay, let's plot our points again for the first triangle. Over 2 and up 5, over 2 and up 7, over 5 and up 7. Okay, we can see that this is going to make a right triangle with a rise of 2 and a run of 3. So that gets our slope already. Okay, let's do the other triangle. Over -2 up 2, over -2 up 2, and over 4 up 6. So hopefully you notice that there's no way we can even make a triangle there. So that was probably a mistake on the part of the people who made this. So obviously there's no triangle, so I guess our answer in this case would be neither. Okay, letter C. So over 3 up 4, over 1 up 4, and over 8 up 12. So over 8 up 12. So I'm going to be somewhere up about in here. So that's fine if we extend this a little bit. Let's go ahead and connect those. All right, hopefully you notice that it doesn't make a right triangle. Okay, and let's do the next one. Okay, over 1 down 5, over -2 down 6, and over 2 up 5. Okay, let's go ahead and connect those. Now this looks like it might be a little bit closer. So what would we do then? Well, we're going to go ahead and check. First, check visually. Well, you see that the triangle in the red right here has a line going horizontally, whereas down here we don't have one. So that tells you right off the bat that they're not going to be the same. So neither. Let me just double check. Make sure I didn't make any mistakes. Over 3, over 1 up 4, over 8 up 12. Oh, I see where I made my mistake already. Nope, I didn't. Over 1, -5 was right there. Over 2, down 6. Over 2, up 5. Yep, so those are both correct triangles, but they're not the same. All right, consider a slide. The top of the slide is 7 feet from the ground. Okay, so here's the ground. Okay, let's make our slide. Go ahead. Here's our ladder. Okay, I'm going to make little marks so I remember that. This is going to be our ladder going up the slide. The base of the slide is 10 feet from the ladder. So let's mark that over here. Okay, so our slide goes like this. What is the slope of the slide? Well, let's put our information in. So this is 7 feet right here, and this is 10 feet. So what's the slope? Well, we know that the ground is horizontal. We know that the ladder is vertical. So right there is our slope triangle. We don't need a graph to actually see that. So we know that slope is rise over run. So the ladder went up 7 feet. The run, which is the base from here to here, was 10. So our slope is 7 over 10 for this we'll call the hypotenuse. If you were at the base of the slide, which is right here, and moved 2 feet closer to the slide, how high is the slide at this point? Well, we have to figure out how long the slide is to do that. Because what we're going to do is take then this right here and we're going to move it over. So we have to figure out how long it is. Well, this is a right triangle. We know that because we have a 90-degree angle there. So now we can use the Pythagorean theorem. A squared plus b squared equals c squared. We know the two legs make our slope triangle, so I have 7 squared plus 10 squared equals c squared. So 49 plus 100 equals c squared. So that's 149 equals c squared. We know that we do the opposite of squaring, which is square root. They cancel, so c is going to be the square root of 149, which I know is between 144 and 169. So that's going to be between 12 and 13. Remember, I'm just finding the square root of each of these. We had that lesson. Okay, so it's much closer to 144, so I'm going to just estimate without a calculator. So I'm going to say it's about 12.2 feet. That's how long this is right here. Okay, now I have to move it 2 feet closer to the slide. So how high is the slide? So if I can actually take this, pretend I move it over 2 feet, and kind of bring it up here where it might have been, right? Now we have some new measurements. So this distance right here is what we're actually trying to find out, and then we're going to add it to the 7. We still know the slide itself is 12.2, but now this was 2 feet closer. So now this distance from here to here, and I'll make that red, would now be 8 feet. Okay, so how high? Well, if I know this is 12.2 and this is 8, now I can figure out this using the Pythagorean theorem again. So let me move this down just a teeny bit. Okay, so again I have a squared plus b squared equals c squared. Okay, now this time I'm trying to find this one over here, so we'll call that a. So we know one leg is 8 squared. We don't know the other leg. And we still know the hypotenuse is now 12.2 squared because the slide didn't change. So that's 64 plus b squared equals 12.2 squared. Whoops. We have to actually figure that out. So I'll use a calculator to do that one. Grab one. So 12.2 times 12.2 is going to be approximately 148.8. Okay, to solve this, we have to get the b squared by itself. So I'm going to subtract 64. Subtract 64. So you can see how your knowledge of solving equations would help you. Those cancel, so I'm left with b squared equals, well, if I subtract, I get 8, 4, about 84.8. Okay, we need to get the b by itself, so I'm going to do the opposite of squaring, which is square root. So b will equal the square root of 84.8, I know is between the square root of 81 and the square root of 100, because I don't have a square root symbol on my calculator. So I know that's 9, that's 10, and this is really close to 81, so I'm going to call it about 9 point, let's say 9.1 or 2 again. We'll say 9.2. So the ladder is about 9.2 feet now. Okay. All right. How high off the ground would the slide be if you moved the slide base 2 feet towards where the ladder is? That sounds like the same question. I know these are written a little differently. Okay, I moved it 2 feet up here already, right there. How high off the ground would the slide be if you moved the slide base 2 feet towards where the ladder was? That sounds kind of like the same question. You'll have to help me with that tomorrow. This question right here seems like it's the same as that question right there. So unless I'm just not thinking right, we'll just go with that. How far from the ladder would the base of the slide need to be placed if you wanted the slide to have a slope of 1/2? We're going to talk about that in class because the video is already long enough. This will require some algebra, and so we're going to do this in a group to see what you guys get. Okay, other than that, now you can do your homework for the most part. When you get to this question as part of your homework, just try your best doing what I did. You can answer a few of them, and then we'll talk more about it in class.